In this tutorial, I'm going to cover how we're going to move from our graphic organizer, which I have here, the one I used in my last tutorial, the basic one that I created, and I'm going to use this to create a basic workflow that we're going to use for our operations plan. As you can see here, I've got my production system with some general risks, internal and external stakeholders with associated risks with them also. For this week, I'm just going to focus on the production system side, which is going to address our workflow. Now, there are different ways of doing this. You could either, in the real world, you would present this set of risks to the stakeholders and say, okay, this is what we could do. This is the alternatives: continuous, intermittent, or postponement production system, and here's the risks associated with them. And you can either create a workflow for each of these, or you could select one after a meeting and use that one, or you could, or if you have an existing one, you can make a recommendation based upon how you're going to modify an existing workflow. Now, in this tutorial, I'm going to assume that we do not have a workflow in existence. I'm going to basically create a new workflow for a new product. Now, if you're doing a revision of a current workflow, what you would generally do is you would create a workflow of your current production system. And you would do that through either using value stream mapping or just a basic process flow. Either one. The basic thing is you want to get as much detail as possible so that you know how your new workflow is going to look. But for this tutorial, I'm just going to create a new workflow based upon the project that we want to do. So in the first slide I have here, I have a product decomposition. And basically what this does, sometimes you'll hear it called a product breakdown. There's several other names, but basically what we do is we take the top level concept, which basically, and this one is the kid-friendly computer. We're going to develop a computer that's friendly for kids. And we are going to decompose it down to its various levels. Now, if you are creating this from what is called an RP, a request for proposal, RFP, then you would also put down the system or the requirements of the system. Like, for instance, let's say that this was from a request for proposal from a company that wants us to build something. They would say the computer must have a case, must have hardware, must have software, must have peripherals. So between what I have is 1,000 and the level down below, you would basically have each of the requirements between that. So this allows you to identify each of the requirements that your product must have. Conversely, you can have, if your stakeholders came up with a requirements document, says, okay, well, the product that you're designing must have these 4 requirements. You would list the requirements directly below your product so that you ensure that you identify each requirement in your design. Now, in this example, we have 4 sub-assemblies. You have a case, hardware, software, peripherals. I understand that an actual computer may have more, but this is just for illustration purposes only. And underneath each of these, I have, for instance, I have an uppercase and lowercase. Okay, and then for the hardware, I've got 5 components here. So the first thing you're going to notice is that I've got numbers next to each of these boxes. For instance, I got 1,000, and then here I've got 1,100, 1,200, 1,300, 1,400. This is what is called either, this is used for either a bill of materials. Sometimes you will hear it called a work breakdown structure. You may call it a requirements breakdown structure. Depends on what you're doing with it. But for our purposes, we're going to use this for a bill of materials. So what this does is this allows us to create a list of components in a structured way so that we are able to track the materials better. So this is called a modular bill of materials because we break it down into modular sections. So for instance, the 1000 section would be a kid-friendly computer. Anything that starts with a 1000 would be part of a kid-friendly computer. If I had a second one, let's say if I had one that's for senior citizens, a senior citizen-friendly computer, you can make it 2000. So anything that starts with a 2 would be part of that assembly. So here we've got 4 subassemblies, and you notice that the second digit is what differentiates each of these. So we have 1100, we've got 1200, 1300, 1400, and then because I've only got 3 levels, I used 4 digits. So here I have 1110, then 1120 to identify items underneath the case. Then for the hardware, I've got 1200, then I got 1210, 1220. I think you get the idea. So then if I had components under each of these, I'd have, like, let's say if the uppercase has a screw. You can make that 1111. Now, obviously in this example, I only allowed for 10 items underneath each of these components. In the real world, you may have 10000, depending on how complex your components are. Now, I've been asked in the past, what if you have 2 components that share the same part? Like, let's say you have a kid-friendly computer and you have a senior citizen computer 2000, and they each share the same case. How would you differentiate that? Well, you could do either one of 2 things. You can either A, have them both share the same number, 1100, or you would still do a 2100 for a senior citizen case and have what is called a compatibility matrix. And the compatibility matrix, all it is just a simple graph that shows parts between 2 systems, and it shows compatibility. So what this does is this is loaded into your material requirements plan. And with this also, and what this does is, so if a person comes up and types in case 1100, it will come up with the case, it'll come up with the part number, it'll come up with parts that are inside it. It would show, the decomposition 1110, 1120, and it'll also show compatibility. So let's say you're building your senior citizen friendly computer and you run out of cases. Your logistics manager or your supply chain manager can bring up the MRP and go, oh wow, we can use the 2100 case as well. So they would be able to pull that case from the inventory of the other design for use in your computer. Now, of course, then you have to talk about the logistical side of how it's going to be replenished and things like that. But that's what a compatibility matrix provides you. It provides you the ability to see at a glance what is compatible between designs. They're pretty common with an MRP. So now we have our bill of materials, or your work breakdown structure, or your material breakdown structure. What this also allows us to do, I have not covered this yet, this also allows us to develop processes for each of these components. So let's say, for instance, if I'm creating a work breakdown structure for all of this stuff here, the procedures would be numbered, like 1000 would be like how to build a kid-friendly computer. Then all the procedures to build the case will be numbered 1100. And within a design system, usually the procedure for manufacturing or designing a particular component will share the same number as the part number. So if I had a system that had drawings for all of these things, what I could do is I could go to my drawing system and type in 1100, and it'll show me the drawings for the case, the specifications, the tolerances, how it's designed, whatever I get, either we send that off for internal manufacturing for them to build a case for us from raw materials, or we can send this off to a manufacturer. The manufacturer would use this number for the case. And let's say we have a revision. We'd have 1100-1-2-3-4 to denote changes to cases. We may end up with 5 different types of kid-friendly computer, and each case may be -1, -2, -3, -4, -5. Maybe differentiate between blue or red or green or whatever. Okay, so, and in these drawings, the drawings will typically have the parts that go with that case. And linked with the drawing will also be procedures for how to build a case. They will be usually kept in a different database, but sometimes I have seen where they will put those procedures in with the drawing so that the person who is responsible for building the case, when they pull that drawing, they also get the procedures for building that case also. I've seen both ways. So that's generally how we use this information. This allows us to, one, create a bill of materials from the top level all the way down. That allows us to make a database of every part that is used in our kid-friendly computer in this example. It also allows us to maintain drawings for each of our sub-assemblies and our main assembly, and it allows us to organize all these drawings so that it's easier for the person who requires the drawings to pull them as required. It also allows us to categorize our procedures as they're created using the same system. So this numbering system is very important as we go forward. Now the workflow. Basically what I did is I take all of the components in the decomposition and I basically place them on a sheet, and I basically put them in an order that it makes sense for assembly. In this case, I said, okay, I'm going to build the lowercase and the uppercase at the same time. So I've got two assembly lines here. So the first one is the lowercase 1120, and at this point I'm going to install the motherboard first, then the graphics card, then the memory, then the sound card, then the hard drive, then the mouse, and then the keyboard. In the real world it may be different, but for this example, this is just how I design it for this example. Then at the same time, for the uppercase, I just basically said there's a monitor and the speakers inside it. Made it very simple, but I made sure that each of the subcomponents were reflected in the design, and each of the subcomponents is a light blue color. So now when you do this, what you can do, if you have an existing work assembly, an existing workflow, what you could do is you can basically plot all of these as it is currently being made. This is very top level because obviously each of these, like the motherboard may have 4 or 5 processes within that. This is the top level workflow. So you may determine that part of the motherboard and the graphics card are done at the same time. Perhaps they both share some of the same space, so you may have to, while you're putting in the motherboard, you may have to make space for the graphic card, put the graphic card in, and then go back to the motherboard. You would reflect this in a lower level workflow. This is a top level workflow for now. So we basically flow it out to the end. At the end here, we assume that the lowercase is finished. And then at this point, we assume that the uppercase is finished. You can sometimes you'll see a symbol. Sometimes it's a hexagon saying, finished, or it'll have the number of that assembly. So now the final assembly and test. Basically, the initial assembly builds the 2 subcomponents. Then the final assembly, we build the case. So the case is a combination of both the lowercase and the uppercase. We install the operating system. We installed the BIOS. Notice a different color. This is light blue. So this is still part of the sub-assemblies. Now, once the operating system and the BIOS is in, we do a burn-in test. We let it run for a day, make sure that nothing burns up. This would be called an ATP sometimes, automated test program, where basically we're just making sure that everything that we've put inside it is functional. A burn-in test is used for computers. They usually run for like a day to make sure that the components in there don't have any flaws. Usually there's a theory that if a product inside a computer is bad, it'll usually fail within the first day. So they call it a burn-in test. At that point, we're going to do an inspection. Sure, in the real world, you may do the inspection first. This is just for an example. So obviously, or this may be an existing workflow. You may go say, oh wow, we should do the inspection first. Maybe you're having a high instance of failed inspections. So, or a high instance of fails in your burn-in test. So you can move your inspection to inspect the components that are burning up most frequently, especially if this is part of a quality control process where you may say, oh, I found that during the burn-in test, this component burns up because of failure to install correctly. So you may say, oh, I'm going to move my inspection over here. So, but for this example, I'm just making a general workflow. So burn-in test, inspection, final testing, packaging, and shipping. Notice how I have numbers for each of the processes: 1001, 1002, 1003, and so forth. In the real world, you may have this differently because, well, what you need to remember is just that these numbers have to correlate differently than your assembly instructions for your other components. I use the top level one for the computer as a whole, 1000, to denote these basic instructions. And that's generally what happens. You normally have the top level instructions for that part number. So for instance, you may have 1001. Then if you change it 1001-1, 1001-2, whatever, to denote different revisions of that same process. So in this example, I've basically gone from the concept of the kid-friendly computer using the production system recommendations. Now, I didn't go through the recommendations very detailed, but basically you would either create a workflow from an existing workflow, an existing production process, or you would create a new one. Sometimes you may create a workflow for each of the options. You may create one using the intermittent production workflow. You may create one using the continuous production workflow. You may even make one a recommendation using the postponement one, which is the hybrid of the two. Either way, you would create these workflows, and you would include these in your operations plan so that the decision makers could visually see how the design or the design changes will impact the design variables in your design. So I hope this was helpful. And this is generally all that is required for this project. Basically, just make a general workflow. I showed you how to make a bill of materials, which is very important for a lot of things, just to identify all the materials used in construction. It's also used for a work breakdown structure where it catalogs all the work being performed on a certain product. And it's also used for managing things like drawings and other processes. And I also mentioned briefly the configuration matrix, which can be used with a bill of materials for multiple product lines to show a person in an MRP or similar tool compatible parts in the event that you need to share parts. Either share parts between designs, which is common, or in case someone needs to pull a part from another design to prevent a work stoppage. As always, please feel free to provide comments in the classroom as you see fit, and I will do what I can to answer them as soon as possible. Thank you very much.